So today, we're going to pull back the curtain on something that's, well, fundamental to Windows administration, the Group Policy Object, or GPO. We'll be looking at its brilliant architecture, especially as it stands in Windows Server 2025. But to really get why this thing is so brilliantly designed, we've got to start with the problem it was built to solve. Just imagine you're an admin. You need to push out a new security setting, or maybe you need to set a specific desktop background for everyone, or block all USB drives. How do you possibly roll that out across thousands or even tens of thousands of computers without completely losing your mind? Well, the answer is, actually, it's pretty elegant. Instead of trying to touch every single machine one by one, you create a single master rulebook. And that's really the core idea of a group policy object, a centralized set of rules that you can apply to as many users and computers as you need to. Okay, so this is where it gets really clever. This rulebook isn't just one giant clunky file. To make it super efficient, especially for the kind of networks that existed when it was first designed, it's split into two distinct cooperative halves. And understanding these two parts, that's the key to understanding why this system has worked so reliably for so long. I want you to think of it just like an actual book. On one side, you've got the table of contents. It's just a quick summary, right? It tells you what's in the book and what version it is. And then on the other side, you have the rule chapters themselves, all the detailed text, the scripts, all the nitty-gritty settings. Now let's look at what these are actually called. All right, so that table of contents, officially that's called the Group Policy Container, or GPC. It's this small, lightweight piece that's stored right inside Active Directory, which is basically the network's central phone book and identity database. Storing it here was a very deliberate choice. It doesn't hold the rules themselves, just the information about them. The GPO's name, its version number, and whether it's on or off. It's kind of like the administrative wrapper. And then you've got the rule chapters themselves. The official name for that is the Group Policy Template, or GPT. And this is the heavy lifter. It's a collection of files and folders tucked away in a special shared folder called sysvol, which lives on every single domain controller. This is where you find all the actual stuff, the security settings, the registry files, the scripts that are going to be enforced on the client machines. Okay, so let's recap. We've got this rulebook, right? But it's split in two. The table of contents is in one place, and the chapters are in another. So how in the world do you keep everything in sync across your entire network of domain controllers? Remember, back when this was all designed, network bandwidth was a precious, precious resource. This separation was the key.
Well, for the GPC, that lightweight table of contents, the network uses its absolute fastest delivery system. And that system is standard Active Directory replication. Because the GPC is just a tiny little bit of data, it can piggyback on the Core 80 engine, a system that's literally designed for frequent, small, and urgent updates. So when you change a GPO's version number or flip its status, that change just flies across the network almost instantly. It is built for speed. And how fast are we talking? Well, typically, it's less than a minute between domain controllers that are in the same physical location. This speed is absolutely critical. It makes sure that every server knows immediately that a new version of the rulebook is out there, even before they have the new rules themselves. It's like a network-wide heads up. Okay, but what about the actual chapters, the GPT? I mean, these can contain big files like scripts or new templates. Trying to send those through that same rapid-fire channel would have been a disaster on older networks. It would have clogged everything up. So it uses a totally different, more robust system that's designed specifically for files. That's where a different system comes in, and it's called Distributed File System Replication, or DFSR for short. It's built from the ground up to handle synchronizing entire folders full of files across a bunch of different servers, making sure that every copy of those rule chapters is a perfect match, even if it takes a little bit longer. And yeah, the time difference here is pretty significant. Full synchronization of the GPT files with DFSR can typically take around 15 minutes. It's a very deliberate trade-off. You sacrifice a little bit of speed for the rock-solid consistency you need to make sure every domain controller has the exact same set of rules, all without bringing the network to its knees. So, that's the classic architecture that has been the backbone of Windows networks for, well, years. But what about Windows Server 2025? Did they just tear it all down and start over? And the answer, maybe surprisingly, is no. And honestly, that's a good thing. Instead of a risky rewrite, what we get are refinements. Server 2025 brings overall security and performance boosts to the systems underneath, making both AG and DFSR replication faster and more reliable. It also ships with way better default security templates, so your rulebooks are more secure right out of the box. And really, that says it all, doesn't it?
The fundamental design of splitting the GPO into a GPC and a GPT is just so solid that it doesn't need to be replaced. It's a real testament to good engineering, and Windows Server 2025 just tunes the engine to run better than it ever has before. So let's just zoom out one last time and appreciate why this decades-old architecture has really stood the test of time and why it's still at the very heart of Windows management today. The whole thing is just a masterclass in balancing trade-offs. You get that near-instant notification of a change happening thanks to the fast GPC replication, while the larger, more sensitive role files are reliably and safely synchronized using the slower but much more robust GPT replication. It really is the best of both worlds, born out of a very real need for both speed and accuracy. It is an incredibly resilient design that has managed billions of machines over the years. And while sure, cloud-based management tools are definitely on the rise, this core system remains a proven workhorse. And that leaves us with one final question to chew on. In a world that's rushing to the cloud, what will it finally take to replace this elegant and enduring rulebook?